Good day, grade 8 students. This is Teacher Paul, your math teacher for week 6. This week's topic is all about triangle congruence, postulates, and theorem. At the end of the lesson, you should be able to state and illustrate SAS, SSS, ASA, congruence postulates, and SSA congruence theorem. And you should be able to apply the postulates and theorems on triangle congruence to prove statements on triangle congruence. How do we prove triangles congruent? Now let's have a short review on the previous discussion about congruent triangles. Earlier, you learned that two geometric figures are said to be congruent if and only if they have exactly the same size and shape regardless of its position. So how much do we need to know to prove that the two triangles are really congruent? You also learned that for two triangles to be congruent, all 6 pairs of the corresponding parts, including the sides and angles, should be congruent. So for these two triangles ABC and triangle DEF, if all of the following 6 pairs of corresponding parts are said to be congruent, then we can conclude that triangle ABC is congruent to triangle DEF. Do we need all 6? No. And that's where triangle congruent theorems and postulates come in. We will talk about these 4 postulates and theorems that are needed to prove triangles congruent without even identifying the 6 pairs of corresponding parts. Our first postulate is the so-called SSS postulate, or side, side, side. This postulate states that two triangles will only be congruent if and only if its 3 corresponding sides are congruent. So from the given figure, we can see, based on the markings, that side AB is congruent to side DE. BC is congruent to EF. AC is congruent to DF. With this information alone, we can conclude the triangle ABC is congruent to triangle DEF because of the side, side, side postulate, because the 3 corresponding sides of the 2 triangles are congruent. The next postulate is what we call SAS postulate, or side angle side. This postulate states that if the 2 corresponding sides of 2 triangles are congruent and its included angle, the 2 triangles are congruent. What do you mean by the word included angle? Included angle is the angle between 2 sides of a triangle. So based on the figure shown, AB is congruent to side DE. Angle A, the included angle, is congruent to angle D, the included angle on the second triangle. And side AC is congruent to side DF. Since the 2 corresponding sides and its included angle are congruent, triangle ABC is congruent to triangle DEF through SAS, or side angle side postulate. Now let's move let's learn further about the included angle. Will you name the angle between these two sides of the three triangles? For the first triangle, angle G is the included angle. For the second triangle, angle I is the included angle. And for the last triangle, angle H is the included angle, since those angles are the angles between two adjacent sides of the triangle. Next, we also have angle-side angle postulate, or angle ASA postulate. This postulate states that if the two corresponding angles and the included side of the two triangles are congruent, the two triangles are said to be congruent. What do you mean by the included side? The included side is the side between two adjacent angles of a triangle. So, based from the markings, we can state that angle A is congruent to angle D. Side, included side AB, is congruent to the included side DE. Angle B is congruent to angle E. This information alone can make us conclude that triangle ABC is congruent to triangle DEF, since it satisfies the definition of the ASA, or angle-side angle postulate. Name the included side between the given two angles of the triangle. For the first triangle, the side between the two angles is side GI. For the second triangle, the included side is side HI. And for the third triangle, the included side is side GH. Lastly, we also have the angle-angle side, or AAS theorem, which states that for the two triangles to be congruent, the two angles and the non-included side should also be congruent. Non-included side is the side that is not between the two given angles. So from the figure, angle A is congruent to angle D. Angle B is congruent to angle E. Side BC, the side which is not between the two angles, is congruent to side DF. Using AAS theorem, we can also conclude the triangle ABC is congruent to triangle DEF. So, always take note that there are only three postulates and one theorem to be used in proving triangles congruent. There is no such SSA postulate and AAA postulate. In summary, you can use any of these four to prove triangle congruence. Note, however, that there are only four, not six. We don't have SSA and AAA correspondence. Another things you have to take note in proving is that overlapping sides, like this one, are congruent through reflexive property, since they share the same side, since the two triangles share the same side. Also, the vertical angles, these angles, are always congruent, and the alternate interior angles are always congruent based from the parallel lines cut by a transversal. To deepen understanding, let's have some examples. Listen carefully because the examples are patterned by the questions written in your activity sheets. Activity 1 is entitled, Which Congruence Postulate? You have to draw the correct markings showing the congruence postulates and theorem. Number 1, we have to prove that the two triangles are congruent through SAS, or side included angle side. So you just have to take note of this. The side marked with one line is always congruent to the other side marked with one line. The angle marked with one arc is congruent to the other angle marked with one arc, and so on and so forth. And here is the answer. For the two triangles to be congruent using the side angle side, we have to mark the two corresponding sides congruent and its included angle, or the angle between the between the two adjacent sides. So how do we know that these two angles are congruent? So we learned that vertical angles will always be congruent. So the markings alone help us identify what congruence postulate or theorem was used. For number 2, to prove the two triangles congruent using ASA, or angle side angle congruence, we have to mark two angles and included side. The included side, or the side between the two angles here, are also congruent using the reflexive property, since they share the same side. And alternate interior angles, this one, the angle formed by parallel lines, cut be a transversal, are also congruent. So these markings show the correct congruence postulate or theorem. For number 3, for these two triangles to be congruent using SSS congruence, we have to show that the three corresponding sides of the two triangles are congruent. So marking this side with one line and the other side with one line, the remaining side with two lines, and the overlapping side, through reflexive property, the two triangles are now congruent using SSS congruence. For the last figure, we have to draw the correct markings to show that the two triangles are congruent using angle-angle side congruence. So we just have to mark two angles and non-included side congruent. Now, since from the given, this angle shows perpendicularity, or a right angle. Therefore, since the two triangles form a straight line, the other angle also measures 90 degrees. And through reflexive properties, since the two triangles share the same one side, we now prove that the two triangles are congruent using the angle-angle side